Hi, and welcome everybody. I'm Carl Smith, Manager Professional Solutions here at IMAGINiT Technologies.
And I'm Ed Gillman. I'm a manufacturing applications expert at IMAGINiT.
All right, welcome again, and let's get started. So today's event is going to focus a little bit on the manufacturing process and connecting the CAD, CAM, and the general manufacturing process in general. We know that as products are becoming more sophisticated and more complex, new materials are being applied and new technologies are becoming available. It really challenges the status quo, what we're going through today, and it requires traditional manufacturers like yourself to think about how we're going to change in order to compete. Traditional views of manufacturing are changing from what is commonly thought of to something that will align with the future. Things are becoming better suited to human needs, more customized, more configurable, more connected, and ultimately more valuable to us. In the realm of making, new technology is being introduced in the forms of processes, materials, and the way information is gathered. And the work we do is changing as the processes of design and making converge. We're seeing entire industries themselves converge like never before as companies and supply chains are increasingly interwoven in a modern, connected world. As you'll see throughout this conference, Autodesk and Imagine have identified these issues across manufacturing, have been attacking them with technology and supporting them with our consultative services. A company looking to succeed in the future will want to connect design to manufacturing within a single platform so you can take your designs and apply standard or emerging manufacturing methods to quickly deliver the processes to the shop floor. Generative design is one of our biggest steps forward in connecting design to manufacturing, for example, leveraging both physical and manufacturing constraints to create hundreds or even thousands of design iterations. Our customers are using this today, not only to design, but to inspire. By leveraging technology from our specialty products, we can automate repetitive workflows like hole drilling and nesting, and we can also use this automation to quickly explore all solutions when it comes to shape and manufacturing processes. And by automating these repetitive workflows, customers have more time to focus on innovation and optimize their processes. But if we take an honest look at the manufacturing process holistically, we can see that it is generally and relentlessly linear while having a feeling, and only a feeling, of being unidirectional. We start with an initial concept, work through CAD workflows to further detail the design, further engineer for performance by applying specialized technologies and tools, determine the manufacturing process, plan the process, and source the materials and equipment, move into production, and finally ship the product. At a closer look, we can see that there are numerous points of friction, however. Workflows are complex and often disconnected, which leads to delays and inefficiencies in manufacturing, often forcing rework and manual repetitive tasks. In fact, if we were honest, we could break down just one area of a typically broken process and the focus of today's session. It's a reality that most manufacturers have isolated workflows, especially between the design team and the manufacturing team. There's no traceability really between what may be the drawing or the inventor model or of any sort. It's really, there's really nothing happening between the CAM project and the CAM files, the code base, the tool database, all of that kind of stuff is typically a problem when we examine it. There's no feedback loop, knowledge sharing, anything like that, other than maybe just very elementary or very rough methodologies for doing so. There's no link between the CAM project and the NC code. It's just often a text file sitting on a thumb drive somewhere. And even the NC code can be edited by the machine tool operator himself, and really no record of these changes will review if errors occur. So by connecting these things, the CAD office's releases versions to be worked on by the CAM office. That's what we want to do. The CAM office can then release these to the shop floor for manufacturing. In a perfect solution, any changes upstream cause a notification like an email to downstream stakeholders for review. Even if NC code is changed on the shop floor, the new revision can be checked into Vault and feedback upstream can be given in order to improve future CAM programming. So the benefits of a connected process like here are huge. I mean, we have traceability to CAD. We have revision control, something we kind of neglected in the CAM industry for a long time. Life cycles for CAM projects, approvals, approved states, those kind of things. Notifications when updates occur in CAD and when updates occur in CAM, back and forth. So there's a great amount of feedback. And then the shop floor application allows efficient delivery of NC code to machines directly from the Vault. So that's what we're after. And Ed is going to talk a little bit about that in his section of this presentation today. Kind of give you a little real world examples on what's happening out there. So Ed, if you are ready to go, I will turn the presentation over to you, sir.
All right. So like Carl mentioned, I'm going to continue to highlight some of the problems that we have connecting data between the engineering team, CAM team, the sales team, and the shop floor. So I'm going to further highlight several items, and then I'll also show you some ways that we can combat these issues and solve these issues with CAD, CAM, data management that Autodesk provides. So I wanted to show this slide so that you can get an idea for where problems occur on the shop floor. If you make all of your changes within the CAD file and you just release the file to manufacturing, after the NC code is generated by the CNC programmer, this is all you have to go by. So we're looking at these two files side by side and trying to determine which one is the latest release. I don't know which one of these is Rev A or Rev B, and most people outside of the CNC programming team are unlikely to be able to tell the difference. So we can solve this issue by managing our CAM data in a product data management system so that the design and the NC code is all held together in one single place. So let's consider an engineering design change. This could be something simple like a hole diameter needs to be changed. It could be something more complex like a complete rework of tooling. Ideally, the engineers will make the change, and with an integrated process, a product data management process, such as Vault, you could check in that file to Vault with an initiated change order. Now, this is the missing link that we typically see. From here, sometimes the file goes right out to the CNC programming team to generate NC code. But if you include manufacturing in that product release process, they can add their own CAM toolpath, verify that they have the correct fixturing, the correct material, the correct tooling to complete the job, and then generate the NC code. This data, the CAM toolpath, the NC code, that can also be checked into Vault with the file. And that presents a lot of advantages because then when it gets released to the shop floor, the CAM team, the CNC programmers, have already seen the file. They've seen the updates. They're aware of what fixturing needs to be put in place. They're aware of what changes have been made to the NC code, and nobody is getting blindsided. So this automatically creates more collaboration between the teams, which leads to several advantages. We're identifying manufacturing obstacles prior to release. We are identifying where issues may occur. A design change by the engineering team could cause difficulty on the manufacturing floor. Maybe you don't have the correct machine to make that change or to create that feature. These problems can be found earlier. You can prevent mistakes. One of the biggest things I've seen is that the wrong revision will be manufactured because the wrong file was released to the shop floor. This makes sure that everyone is working with the correct revision, the newest release, and the correct geometry. You also get an improvement in the product quality, right? We can improve collaboration, find out ways to make products better, to make products more accurate, and improve our overall sales. So one of the ways that Vault helps us is that once we've generated that NC code, we can attach the NC code, like shown here, to the part file. So when this part file is released and it goes through the change order, the design team can verify that the geometry will work as desired. The manufacturing team can verify there's CAM toolpaths that can create the part, as well as the NC code has been updated and attached. If you have a customer who needs another version of the part, you can go grab that part file from Vault, and the NC code will be with it. The NC code isn't floating around on someone else's computer or hard drive. It is directly attached to that part file. Let's not forget about sales. How can we help out the sales team with a process like this? One of the ways that we can include purchasing as well as sales is within our engineering change orders. Within Vault, you can create custom routings. So I can choose who gets to see the design change, who needs to approve it, and that way when it goes through the release process, everyone is aware of the change and how it might affect their department or their responsibilities. So you're providing sales with accurate information. What is the latest part? What does it look like? How does it function? And how does it help your customers? Is there a new feature that might improve sales? The sales team should be made aware of what is going on in the engineering department. The best way to do that is by including them on these change orders. You can generate quotes faster. So being able to understand how long something will take to manufacture. Typically that data resides only on the shop floor. You have to go out to the shop floor and ask the CNC programmer, how long does this take to make? How long does this take to set up, machine, and finish? This data could then be shared with the sales team during a change order so that they are aware of how that impacts sales. The current lead times as well. Is there a back order? Is one of the machines down? What limitations are currently in place? You can automate quoting as well. So with Inventor CAM and the other Autodesk CAM platforms, you will get an estimate of the machining time. So shown here, this is going to take 20 minutes and 23 seconds to machine. That information lies within that file that will be going through the change order release process. That data is then shared with the entire team. So everyone knows how long it's going to take to machine the part and how that impacts the workflow and scheduling. You can also generate cost estimates with macros. You could use Excel, you could use macros and iLogic that are built into Inventor to automatically update the cost of a component based off of the machining time. And finally, how can we better collaborate with the shop floor and really bring together our engineering team, our manufacturing team, purchasing, sales, the whole company? One of those ways is creating this digital feedback loop with manufacturing. Carl showed a nice workflow in his slides, and this is what it would look like in Vault. So this is the actual product put into action to help you out. Within Vault, as you make a change order, if the manufacturing team finds that the design change is impossible to machine, maybe it causes issues on the floor, maybe they don't have the tooling to create that change, they can reject it and send it back to engineering with notes on what needs to be changed. So you don't spend a week going back and forth. You can make this information known immediately so that the engineering team can better design moving forward and prevent those issues before it's too late. So we're creating a feedback loop. We're giving each other information. We're sharing that data. We can also leverage integrated CAD/CAM. So integrated CAD/CAM, like Inventor and Fusion 360, are built so that the CAM information, the toolpath that I'm showing here, simulating cutting the part, that information is saved with the actual CAD data, which means if a change is made to the design, you can automatically see those impacts on the CAM toolpath and update the toolpath so that it is relevant, it is recent, and you can verify that it still works despite the design change. It also allows you to verify that there aren't any collisions and that you have the correct tooling to manufacture that part. And finally, you can prepare fixturing. You can plan out what fixtures need to be in place. You can plan out what tools you need. Maybe you need to order a new end mill or a new drill to make that change. You can plan that purchasing decision much earlier in the process with integrated CAD/CAM. One last discussion here is how we can build a relationship between engineering and manufacturing. Vault is definitely one of those ways to do that, as well as integrated CAD/CAM. And what we're trying to do here is educate the design team on how their changes will impact manufacturing processes. So you're allowing the engineering team and the shop floor to directly coordinate how they're going to design a part, because engineering can get a better understanding for what their changes do and how it affects what tools are selected, how it affects machining time, as well as what material to use for each process. So you're creating collaboration between the two teams. This allows for ideas to be shared. Maybe there's a way to improve the process and machine things faster or more efficiently, as well as when issues occur and problems come into play, you can work together to solve those problems. Engineering and manufacturing, putting all of their minds together to solve problems. So I wanted to show a quick example of what this workflow would look like within Inventor, Inventor CAM, and Vault. So we're going to be looking at this dust collector. And looking at the dust collector here, we're going to be making a change to the header assembly. So if I zoom in here, this assembly right here is the header assembly. We're going to be making some changes to the bar going across the top and updating the hole diameters. So typically what would happen within Vault is engineering could locate the part. Notice here it's a work in progress. It's currently being designed. When they're ready to release, they can take this part and add it to a new change order. When they do that, they can give it a title. They can say update header hole diameter. They could enter a detailed description. So changing diameter for new design, whatever information needs to be added to that description. Now, when this is put through Vault, you can choose who gets to see this change. So if I specify my engineering change routing, that means that first it's going to go to the CNC programmer. So after I am finished making the design change, the CNC programmer will need to update the CAM, generate the NC code, and prepare all of the tooling. It'll then go to Dave Designer, so the design lead will make sure that the design has been updated properly. Management can check that this design will not affect the overall assembly and the function of the product. And then it also can be sent to Poly Purchase here, so the purchasing department, as well as Sally Sales. You can send it to the Sally Sales department lead and make sure that they're included in this decision as well. Again, we're building that feedback loop. Everybody gets to approve the change, make their comments and contributions, and avoid errors further down the line. Save yourself days, potentially weeks of back and forth. So once a design needs to be changed within Inventor, the design team can come in and modify these holes. So let's say this valve hole is being updated. Currently, we have a 3-inch diameter at the top. Maybe this is going to 3.25, so we're increasing the diameter of the upper hole, and the lower hole, maybe we're updating that by 1/4 inch as well. So we're making changes to the part on the engineering side. What engineering can do is check out this design and say update holes. Once they have the part checked out, they can update that change, check the part back in, and on their side, they're finished. Now, this will be routed with the change order so that then what will happen is The CNC programmer will then come in here, open the part. They'll see the comments that engineering made, and then they can go to the CAM interface within Inventor. And what you'll see here is the drill, the pocket, and the finishing pass on all of these features is currently showing up with this red X. That means that the CAM data is out of date, which means the design change that was made is affecting the toolpath that the CNC department already created. So what the programming team can do is come in here and regenerate the toolpath, make sure that it still works. So we'll check it out, make a change. So the pre-drill, pocket, and finish, update those toolpaths and simulate. We can simulate the tooling, make sure that the hole still maintains clearance regardless of what tool we're using, and verify that this will work on our current machine. Once the CNC programmers are happy with the toolpath, they can save it, check this back into Vault and say updated CAM toolpath, and send it along its way. So right away, you get that initial and immediate collaboration between engineering and manufacturing. The design team makes a change to the holes. The CNC programmer notices that that affects the toolpath and updates that data immediately, verifies that there aren't any collisions, checks it back in, and now this can be pushed through to management and sales for final release. So the advantage here, like I mentioned before, is that we are doing a better job planning. So we're identifying what fixturing and tooling is needed earlier in the process. We're sharing data between engineering and manufacturing. And we're improving the product quality by working together collaboratively to address problems and release new parts. Thank you for joining us today at the Elevate event. We are now going to open this up for Q&A, so if you have any final questions, feel free to ask our panel for the next few minutes.